Hello everyone. This is going to be problem number 1 from the worksheet Dr. K handed out on balancing redox reactions. So the first thing you really want to do when you're working on these is separate your your chemical reaction here into your two half reactions. So you're going to figure out which parts are being oxidized and which ones are being reduced. And remember, when it's being reduced, they're gaining electrons, and when it's being oxidized, they're going to be losing electrons. A lot of times you can figure out what your half reactions are going to be by looking at a chart, but sometimes you can just kind of figure it out by looking at your actual reaction. For example, I know that the two iron elements here are going to go into one half reaction, and I can tell from the charge that it must be oxidized because it lost electrons. So let's write that down here. Alright, I've got that written out, and I know that it's going to be 1 electron because if you add up the charges on the two sides, over here we get a 2 plus charge, and over here you get 3 plus and 1 minus from the electron, which gives you a 2 plus charge, so you know that's how you would balance that part of the half reaction. So now we can go ahead and write the redox half of our equation, or reaction. Okay, there we go. So we don't really know how many electrons we want to put into this half reaction yet, because we have this oxygen right here, and it's kind of messing up what we would normally do. So when you're balancing these half reactions, the first thing you want to do is balance all of the elements in the equation other than your oxygen and your hydrogen. So we've got 1 manganese on both sides up top, so that's good. We've got 1 iron on both sides, so this one's really easy. Next, we want to move on to balancing this oxygen because we have to deal with that aspect of it. So the first thing we're going to do is add water to the right side of that half reaction. So because there are 4 oxygens on the left, we're going to add 4 water molecules on the right. And now our oxygen balances out for that half reaction, but now the hydrogens don't match, so we're going to have to add 8 hydrogens to both sides. And I'm going to go ahead and erase this part here because I'm going to need the room. Okay, so now that we've got all of our elements, including hydrogen and oxygen, balanced, we can move on to balancing the charges of both sides. And we already established that the iron half reaction was balanced. So now let's look at the top half reaction. So from the hydrogen we have 8 plus for our charge, and over here we have 1 minus, which brings our total charge here to 7 plus. And on this side, the water isn't adding anything to the charge, so our total charge over here just comes from the manganese, and that makes it 2 plus. So in order to make these two sides equal, we are going to have to add 5 electrons to this side. Let me go ahead and clean that. Alright, so now that we have the charges for both half reactions balanced, we can make sure that both sides of the reactions can cancel out for the electrons. So what I'm talking about are these electrons and these electrons. We need them to cancel out, but we have 5 on the top left and only 1 on the bottom right. So what we're going to have to do is multiply this entire bottom half reaction by 5 so that we have the same number of electrons. By doing that, we can now cancel out the electrons. And at this point, we're going to want to just add everything together that you haven't already canceled out. So I'll write that below. Okay, so at this point, I've just added everything together, and the only thing left to do is to just check to make sure that everything balances out correctly. So you'll just want to check your elements. So you've got 8 hydrogen here, 8 hydrogen here. Okay, check. Oops, bring that back. We've got 1 manganese, 1 manganese. We've got 4 oxygen, 4 oxygen, 5 iron, and 5 iron. So that all balances out. So next, you want to see if your charges balance. So over here we have 8 plus, 1 minus, 10 plus, because 5 times 2. And then that all comes together to be 17 plus overall on the left. Here we've got 15 plus, 2 plus, and here 0. All of that comes together to also equal 17 plus. So the charges balance, all of our elements balance. Therefore, we have our final answer for an acidic solution. If this were in a basic solution, you would have to do more steps to make that work, and you'll see that in problems number 3 and number 5 on the practice sheet. Thanks for watching. Good luck on the test.